Hi everyone! Welcome! Today, we're excited to show you how to unlock even greater value from PlainID's powerful platform, with a special focus on its robust API access control capabilities. In today's world, businesses must manage access to data, microservices, APIs, and applications efficiently while ensuring compliance with security policies. PlainID's authorization platform helps you achieve just that in a click, by leveraging a policy-based access control framework to exemplify this approach. This framework enables enterprises to define and manage access policies centrally, using natural language and graphical interfaces that non-technical stakeholders can easily understand and engage with. In this session, we'll provide a deep dive into how PlainID's API access control authorizer pattern enforces secure policy-driven access dynamically and effectively. We'll examine the real-world challenges enterprises face, focusing on the business perspective and demonstrating how PlainID's centralized policy management addresses these gaps with precision. Additionally, we'll guide you through a hands-on demonstration of effortlessly streamlining and managing access policies, with a focus on the powerful capabilities of API matchers and mappers, which establish an abstraction layer to align diverse APIs with a unified business logic layer. This approach is governed by global policies, guarantees efficient and consistent access management across all APIs. Finally, you'll uncover the architecture and benefits of PlainID's API Authorizer, showcasing its ability to seamlessly integrate multiple services with diverse patterns under a single, unified policy framework. So let's get started. Let's dive into the scenario. Our demo company, a financial corp, is a fast-growing enterprise specializing in wealth management, investment advisory, and corporate finance solutions with sensitive data consumed via numerous API services. The Corp's digital resources include data for employees, accounts, departments, and more. The current gaps in their access control system allow users to view and manage data they shouldn't, leading to a potential security breach.
Hello, my name is Brandon, Security Team Manager in the financial company. We've got multiple services that give access to sensitive data and enhance required protection. Our main concern right now is our checking account service. This service allows our wealth managers to access their customers' accounts, but we need to ensure that each manager can view only the accounts assigned to them as the designated relationship manager in the CRM. This means the REST service expects to get user correlation and additional parameters that come from user JOT.
Hi Brandon, my name is Ava, a product manager in PlainID. Nice to meet you. This is a common challenge as companies expand their services and need more fine-grained access control. With PlainID's platform, you can centralize your access policies, making it easy to ensure that only the right people access the right resources. Now, let's see how it works using the PlainID platform. To onboard a new use case, the first step is to create templates. These are the objects that bridge the logical and physical layers. This approach empowers non-technical users to easily manage and create access policies within PlainID. So first, we'll navigate to the Identity Workspace. The Identity Workspace is where you manage all your identity attributes. Because many organizations maintain multiple types of identity definitions like internal users, external users, partners, and more, the information for each type of user may come from different identity sources. Considering your challenge, we need to ask ourselves, where does the user information come from? Is it stored in the same identity source? Does it represent the same identity type? For example, in Financial Corp, we know the goal is to secure managers' access to customer accounts. On the who side, we're dealing with managers who are employees and their information is different and managed separately from the customer's information. This is why we need to separate and utilize different workspaces for each identity type, one for the customers and one for the employees. Each workspace is designed to support only one main source. In API use cases, it's common for a workspace to be linked to a specific JOT via its associated matcher value. Consequently, the attributes are unique to the identity workspace in which they are created and cannot be shared across other workspaces. Now, let's take a closer look at the identity attributes that will play a key role in this policy. Identity attributes determine who will be granted or denied access to an asset. Therefore, we will define only the identity attributes that are essential to supporting the policy logic and rule sets. You can see that the following attributes are managed for employees: User ID, Device Authorization, Relationship Accounts ID, and user specialization, mapped from the JOT claim. Based on these attributes, in more complex scenarios you can also create identity conditions or dynamic groups to define a group based on different cross-sections, such as a manager's specialization, like wealth managers, financial planners, or investment strategies. The next template we'll create is the asset type. Asset types are defined as logical groups of business assets that the organization wishes to manage together and protect. In our case, we want to protect the account information. The asset type includes asset attributes, which serve as the bridge between logical definitions and physical components. We are securing accounts with the relevant attribute for policy enforcement being the account ID. This attribute will be sent within the request to make the correlation with the relationship accounts ID identity attribute we created. We also define the allowed action, view. Now, we will navigate to the application named Gold Finance Portal. This application is connected to the asset type we saw, and also contains the API mapper list following the different services we want to protect. Before we proceed to define the API mappers, let's take a moment to understand their purpose and structure in detail. PlainID addresses the fundamental question: who can do what on what, and under what conditions? This slide showcases two types of policies, basic and advanced policies. The basic policy is a straightforward rule where customers can view their accounts. The advanced policy is a more dynamic rule that incorporates conditional logic. For instance, a customer can approve or decline transactions, but only after successfully authenticating. Now let's shift focus to the API request, which is where the policy enforcement happens. Every request is carefully analyzed to ensure compliance with the defined rules. Let's break it down step by step. First, the authorization header. The request starts with the authorization header, which carries essential details like the user's identity in the form of a JOT token, the authentication method, and other contextual data. This is the key to unlocking the API's resources. Next, we have the URL itself, which is thoughtfully structured to align directly with the policy definitions. In this example, the asset type that refers to the resource we aim to protect, it's the accounts. The specific account we want to access is identified as 001, which corresponds to the asset attribute defined in PlainID. Together, these components enable the system to accurately identify the specific resource being requested. This allows PlainID to map these segments seamlessly within its platform, ensuring that the appropriate access decisions are enforced. These decisions are directly tied to the relationship between the asset type and the policy, ensuring secure and context-aware access control. Now that we understand how PlainID solution seamlessly maps policies to API requests, let's return to the platform and see it in action. We'll navigate back to the API mapper list. Here, you can observe how the match pattern for the Check My Account service directly reflects what we've just learned. You'll notice the asset we're requesting access to, the accounts, is logically tied to the asset type we previously configured. This alignment ensures the API mapper seamlessly enforces the policies associated with the defined asset. Note that this match pattern is highly granular, which is why it is considered as the most match pattern. These types of patterns are prioritized first, ensuring that the appropriate API requests are accurately captured and matched to the correct policies. Now let's navigate to the asset type and map the attributes and actions according to the match pattern we just defined. This mapping allows us to define the business assets that need protection and specify how they should be extracted from REST API requests across different services. We'll configure the asset ID to be extracted from the 6th segment of the path in the Check My Account service. And we'll set the API action mapping. For example, view uses the method get. As we did that, we can define the rule sets that will use the policy. By defining the match between the asset ID and the relationship accounts ID, we will allow wealth managers to access customer accounts assigned to them. After we have completed the setup, we can create the policy. We'll give the policy an intuitive name and description, and we'll select the application. Next, we'll choose the dynamic groups. In this example, we'll use wealth managers. We'll continue to select the asset type, the action, and the rule sets. The final step is defining the conditions. With just a click, you can create a variety of conditions, including IP, identity attributes, date and time, and more. Here, you can see an example where an authorized device and a secure VPN are listed as requirements. The policy will now be displayed in a map view, which provides business users with a clear visual representation of the policy evaluation process. Additionally, representing the policy as code enables developers and technical stakeholders to streamline their processes, including environment migration, backup, and version control, by leveraging PlainID's standardized Rego structure.
Hello, Ava. Our previous issue was resolved swiftly and effortlessly. Thank you for your help. Now, we're facing a new challenge with an added layer of complexity. We've noticed there's an additional service in our app that also exposes account information. But this service looks completely different and has a unique match pattern.
Hi, Brandon. I'm glad we could assist. As you add new microservices or increase the number of APIs, our solution will grow with you. The sidecar deployment model allows us to enforce policies at the microservice level without any changes to the application itself. This ensures that as your ecosystem expands, you can maintain a consistent security posture without sacrificing performance or flexibility.
Great. We're excited to see how this will simplify our operations and improve security.
First, I want to ask you a few questions. Are you still protecting the same assets of account information? Is it still the wealth managers who need access to that data? And last question, do you still want to enforce the same access decisions?
Yes, exactly. The same logic applies to this new service as well.
That's great news. Do you remember the mappers we used earlier? This is exactly what they are designed for. You can reuse the same policy we built before and just map the existing attributes and actions to the new match pattern.
Really? That's so efficient and quick.
Absolutely. It's as straightforward as it sounds. Let's see together how to onboard new service. Let's navigate to the Gold Finance application and add a new API mapper for the Fetch My Account service. Notice that the match pattern here differs from the Check My Account service, but the asset, in our case it is the accounts, remains the same. The matcher defines a pattern that determines how the API call is routed and mapped to the correct destination. Now let's seamlessly map the asset attributes and actions. The asset ID is mapped to the fifth segment of the path in the new service, which differs from the mapping in the previous service due to the variation in patterns. The action in this case is mapped differently than a typical method, utilizing a specific segment within the path instead. And that is how you can create multiple mappings for the same attributes to ensure standardization. This is how the logical and physical components seamlessly connect and work together. See how simple that was? We didn't even need to modify the policy itself because it's already linked to the account's asset type. All we had to do was make a small adjustment to the mapping associated with that policy. The policy you have just built is part of the PlainID API access solution. By implementing the API access authorization pattern, PlainID authorizers add an enforcement point in the flow of applications and services communicating over REST requests. By integrating into API gateways, proxies, and service meshes, PlainID authorizers can intercept API REST requests and dynamically determine whether they are allowed based on the calling identity context or should be blocked as unauthorized. If you asked yourself, how does it work? You have just asked the right question. First, the REST traffic passes through the API gateway and is routed to the PlainID authorizer for a dynamic authorization check. Second, the authorizer translates the request and sends it to the policy decision point for evaluation. Next, the policy decision point uses API mappers to create a standardized access decision request based on the intercepted API call. After, the PDP evaluates the request and returns either a permit or deny response. And finally, the authorizer then allows or blocks the original request accordingly. The advantages of using the PlainID authorizer for API access control are very clear. Let's review them together. The authorizer minimizes the burden on the application by handling access control at the gateway level. It reduces the need for developers to build and maintain authorization logic within each service. The solution integrates smoothly with existing API gateways, proxies, and service meshes, making it easy to implement. The authorizer enables rapid enforcement of security policies across the application's REST requests. By enforcing access control at the gateway, the solution ensures robust and consistent security policies across all services. Dynamic authorization checks at the gateway enhance overall application security by preventing unauthorized API requests in real time. This video focused on the business perspective, demonstrating how PlainID enables defining access policies tailored to business needs and automatically enforcing secure access to API services. We explored PlainID's API Gateway Authorizer, its functionality, and the benefits it delivers, including centralized management across your diverse services and APIs. With PlainID, you can create policies tied directly to business logic, enforceable across different API layers. Our robust mapping layer seamlessly connects these policies to the physical layer, ensuring consistency, standardization, and efficiency. This approach provides a streamlined, business-oriented, and transparent way to manage access policies. PlainID's solution simplifies complexity, enhances security, and accelerates results. For more information, visit our documentation portal to learn more about PlainID's robust Authorizer solutions. Thank you, and see you in our next sessions.